Okay, task 2 today is all about going the other way to what you've done in task 1. So in task 1, numbers in scientific notation and putting them into ordinary form. This task, we're looking at taking numbers that are big numbers and putting them into scientific notation. Now, very much the same tactic going on here about thinking how things come after the 5. So this has got to become a decimal number. Now, this is really important about scientific notation. I haven't mentioned it so far, and that is in scientific notation, we always only have one digit before the decimal point. So here that one digit is going to be the 5. Then we're going to have a decimal point. Then we're going to have 4, 7, 8. Now, we don't need to put all these zeros. That's going to be done by our times 10. Power up here tells us how many things come after the 5. So that is 1, 2, 3, 4, 6, 7, 8 things. So 2 key things coming out of this example. We're still counting the number of things that come after the 5. Second key thing, scientific notation only is scientific notation if you have only got one digit in front of that decimal point. So, just as an example, that is not scientific notation. That is not scientific notation. It's in front of a decimal point. This one, we didn't have a digit between 1 and 5 there. So, sorry, 1 and 9. So that is also not scientific. Please don't write either of them. It must be one digit, and exactly one digit between 1 and 9 before the decimal point. So let's see some more examples of that. First one, we're going to do 6, 3, 0, 0, 0, 0, 0, 0, 0, 0. That one, we'll rewrite 6 with one digit in front of the decimal point, so 6.31 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. So again, I'm counting how many things come after that initial 6. Next example, let's try 72000. Well, that is going to become 7.2. So 7 comes on the decimal point and 2. 7.2 times 10. I've got 1, 2, 3, 4, 5 things. 2 more examples, slightly different in terms of just what they look like. So let's do 7, 4, 4, 1, 8, 0, 0, 0, 0, 0, and 6, 0, 0, 0, 0, 0, 0. Now, this one here, we could write as 7.448. So it doesn't matter how many digits you have here, you still only put 1 before the decimal point. Times 10, how many things come after the 7? 1, 2, 3, 4, 5, 6, 9. So we put power 9 there. This one here is 6 times 10. Now we could write, if you want, you could 6.0 or just 6 times 10. Doesn't matter which one you write. Answer. So 6 times 10 to the something or 6.0 times 10 to the something. And you've got 1, 2, 3, 4, 5, 6 things that come after that 6. Final thing that you might see, this is a bit of an odd case because normally we use scientific notation for really big numbers, or like you'll see next week, really small numbers. 2 cases, if I write the number 90, I could put that in scientific notation. That 9 times 10. What power? Well, how many things come after the 9? Exactly one digit. So it's a slightly odd case. The other odd case is if I just give you a single digit. If I just give you 6, well, we've got 6 times 10. How many things? None. So you could technically write 6 times 10 to the 0 for 6. as I say, very odd cases, we wouldn't normally see these scientific notations usually used to write really big numbers, which would be a pain to write otherwise. So these are kind of ones just to make you aware that you can still write them as scientific notation, but we wouldn't normally do that because it's longer than the original number. Whereas up here, this is much more compact than the original number. The longer our number gets, the better this form becomes for writing it. So have a go at the question, how you get on.